Thank you very much for having me here. It's exciting to hear that type 3 treatments will be implemented on the ground soon. And it's always exciting to talk about future studies and future collaborations. While back, I had a meeting with Teddy, Warren, and Kevin Alexander. It was like a 3-hour marathon meeting, to discuss about how we can estimate treatment cost and so on. And at that time, I suggested that we should do a series of time studies to learn about the operations and the differences between the new treatments and then conventional treatments and so on. So in this presentation, I'd like to briefly mention about what time study is and what it does for us. And then also what kind of cost analysis we can do to estimate treatment cost especially for new treatments. And then we haven't implemented this type 3 treatments yet on the ground. So it's going to be difficult for me to show you the clear ideas, what kind of data we're going to collect and what the study would look like. Because the time study, for example, is a case by case. And then depending on the locations and depending on the purchaser and then the logging contractor, what equipment they're going to bring in, we have to customize our study design for all those variables. So for today, I want to present the recent study that we did. Actually, this is the same study that I presented last year, but my focus was on soil impact last year presentation, but this year is going to focus on the cost analysis. So I'm going to present that study to give an idea what we can do for these type 3 alternative treatments in the future. So the time study basically is a work measurement technique with which we measure and record times times taken to complete a specific work carried by individual machines or personnel in different work conditions. So this is a direct observation method that trained personnel will watch the machine operations or treatments, and then measure time and record them, the time taken to complete work cycle of a operation. For example, this table here shows an example of a cable logging operation, and then work cycle can be defined for cable yarding as a time when time starts when the carriage leaves landing to pick up logs, and then the work cycle ends when carriage returns and drop the logs at the landing. And you can imagine cable logging repeats these cycles. So during time study, we measure how long it takes to complete one cycle, each cycle. And each cycle can be further split into multiple time elements if we want to do finer scale analysis. So in this case, one cycle consists of the time taken to send out the carriage out haul, bring the carriage in haul, or letter yarding operation, or hooking and unhooking, those different time elements. So the time, that's what we measure during time. So that's one big component of data that we collect. The other components of data that we collect includes production. So each cycle time, when we measure time as well as how much wood we move during the cycle. So production is an important data we collect during time study. And the third component is work conditions. So in this case, for example, yarding distance, how far carriage moves, or how far we went out for letter yarding. So letter yarding distance, or the terrain condition like a slope or the vegetation conditions or treatments. They could be different work conditions or different parameters that we collect during time study. So that's the concept of time study in a nutshell. But what does it do for us? The purpose of time study is that it helps us to estimate production rates, so productivity of individual machines or the entire system that apply to a certain treatment in certain area. And then also through the analysis, we can identify the area for improvement. So for example, we can identify the areas of production where time is wasted. So that's the benefit for actually logging contractors, because they can have a clear ideas where the bottleneck exists. Okay. And then if we collect enough data, then we can build regression models regression equations that we can use to predict the productivity of future operations in different work environment. So these are the purposes of time study. In terms of cost analysis, we can collect data and then estimate hourly machine costs, which means that if we purchase a machine or if we use a machine for a certain operation, we want to know how much it would cost to use the machine or to own the machine and so on. So we can usually estimate those costs per hour. So hourly costs include owning cost, which includes depreciation, interest, and insurance and taxes, and then operating costs, maintenance and repair costs, or fuel costs, oil costs, and so on, and labor costs, which is the machine operator wage and then fringe benefit. So this, using this information, we can estimate machine hourly costs. So with that, I mean, time study will provide this system productivity, okay, machine productivity. That's what the time study is for. And then we can estimate machine hourly cost. And then using those two pieces of information, we can estimate treatment cost. And then I want to illustrate how, how we do that using this simple example here. So let's say our logging system, this is going to be, it's going to be shovel logging. So we're going to use fellow buncher to fell down trees. And then we're going to use shovel logger to extract wood. And then we're going to use processor to landing to process timber. And then we're going to use loader to loading timber onto the truck. So let's say that we estimated hourly machine cost, and it's going to be like this, $200 for fellow buncher or $150. This is just a simple example, okay? And then also through time study, we can estimate the productivity of individual machines when those machines work independently. Now, if we assume that we're going to use these 4 machines simultaneously in a logging system or in a treatment, then this processor becomes bottleneck because the other machines can handle more than 2,000 board feet per hour, but this processor can handle up to 2,000 board feet per hour. So this bottleneck function, we can identify that through time study, but at the same time, this bottleneck function will determine the system productivity. So overall, we use 4 different machines at the same time. This is logging, this logging operation, but the production, okay, we will handle or produce 2 MBF of wood, bring 2 MBF of wood to the landing every hour. So with that information, we can estimate treatment costs. So the total cost for 4 machines will be $750 per hour, and productivity will be 2,000 board feet per hour. So that will give us the approximate treatment cost at $375 per hour. So that's going to be unit production cost. So this is how we estimate treatment cost. Now, I'm gonna go into a recent paired study, and so I hope that we can do a series of paired studies for this type 3 treatments. And the reason why we want to do that is because we can really pinpoint if there's a difference, if there's any difference in terms of machine productivity or cost, we can show that, of course, but also we can actually pinpoint where the difference resides and why the difference happens, okay, through these paired studies. So with that, this is again, this is a study that I presented last year, focusing on soil impact of tethered logging, but this time it's going to be economics. So in this study, it's a Lone Rock property in Southern Oregon. You can see this 35-acre clear-cut area, and green area here, we use a tethered machine to cut down trees. And then yellow area, we use hand cut, so timber faller, okay, fell down trees. And after that, we use the same tower yarder to cable log both areas. So the reason why we use the same tower yarder and same crew is because we want to minimize influence from other factors, okay, while maintaining the difference between tether cut versus hand cut. Okay, and then we did this in the same stand so that terrain conditions are more or less similar, and also vegetation condition also similar. Okay, so this is the machine that we use. So anchor machine for tether, and then the tethered bar saw we used to cut down trees. But this tether machine the difference between tether machine versus hand cut is the tether machine can not only cut down trees, but also move trees, swing trees, and pre-bunch logs along the skyline corridor. And that's the benefit. So we want to quantify the impact of that pre-bunching on cable yarding productivity and cost. And then we use the same Thunderbird swing yarder to cable log both areas. Okay, so this is the picture after machine cut. You can see here, machine was able to swing felled trees and then nicely pile them up along the skyline corridor. Okay. And then we did time study for hand cutting. We did time study for machine cutting, machine swing, and then cable logging after hand cut and cable logging after machine cut. Okay. And then we developed regression models for each of those operations. And this is the time study data sheet we used for manual timber falling. And then the map shows where the machines were. Okay, we use a GPS to track down the locations of machine on the ground. And then this shows the the data that we collected during time study. So work cycle will be defined, and each cycle includes this kind of time elements in it, and then variables that we collected during time study. That includes the travel distance between trees, and then the size of trees, and the number of pieces moved, and then the out-haul distance or lateral yarding distance, and so on, okay, for yarding operations. And this, I'm not going to go in details about this data, but this is what we collected, and the number of samples and the average values of cycle time and so on. And this is what we developed. So this is the regression models we developed from the data, the sample data that we collected during time study. So we can estimate cycle time for machine felling or manual felling or cable logging after machine cut or cable logging after hand cut based upon parameters, okay, such as yarding distance, lateral yarding distance, or size of timber, or distance between trees, and so on. In terms of cost analysis, this is the data we collected to estimate machine hourly costs. And then as a result of that, here you can see machine rate here. That's the machine hourly cost. So hand falling about $23 per hour, and machine falling, it's very expensive. So it's about $350 per hour we have to pay to be able to use it, the anchor machine as well as the tethered fellow buncher, okay, and so on. And then this is productivity that we get from time study. So this shows us the productivity for each operation. So again, combining these two pieces of information, we can get the system treatment cost like this. So if you use hand cut and then cable logging after that, the cost would be about $15 per cubic meters. Whereas if you use machine, then the cost essentially goes down to $10 per cubic meters. So through time study and cost analysis, we can show what the treatment cost would be, but having the detailed time study done, we can analyze where the difference resides and what causes the difference. And this is an example here. Actually, if you look at the average yarding distance, because of the unit shape and because of the data collection that we did, so hand cut versus machine cut, the yarding distance was quite different. So machine cut had a longer, okay, machine cut area had longer average yarding distance compared to hand cut area. But because at the same time, because the trees were nicely piled up along the skyline corridor, we were able to grab more trees per cycle. So you can see here a number of pieces that were brought into landing every cycle was about 3 trees or 3 pieces in hand cut area versus about 5 pieces in machine cut area. So even though there are differences like this, but if you look at the cycle time, average cycle time in hand cut area and average cycle time in machine cut area is more or less the same. That means even though machine cut area had longer distance to travel, Okay, it has a similar cycle time, means that machine cut area, the cable logging was more efficient. Okay, and then if you look at the different time elements here, okay, it becomes obvious why this happens. And here, out hole time or in hole time, okay, obviously machine cut area, it takes longer time to send out carriage because of this longer distance the carriage has to travel. Okay, it makes sense. And also unhooking time, it makes sense that machine cut area, it takes longer time to unhook by a chaser because the chaser has to unhook more pieces, more trees, of course, so it takes a longer time. But the large difference came from this hooking time here. Even though the choker setter has to hook almost like double, like 5 trees instead of 3 trees, the time that taken for hooking or choker setting was a lot shorter because logs or trees were there, okay, for him. So the choker setter didn't have to move far away, okay, to find logs or trees. So this is where the difference came from. And then, but this comparison between machine cut and hand cut cable logging efficiency is not apples to apples because we had a different yarding distance, basically. So using the regression model, we can predict, okay, the cycle time at the same yarding distance. So we use the same distance of 531 feet and plug this number to regression equations and predict cycle time, the cable logging cycle time after hand cut and cable logging cycle time after machine cut. And you can see here, machine cut area, the cycle time was reduced by 23%. So it was a lot more faster, okay, each cycle, okay, faster. And then turn size, as I mentioned, we were able to grab more wood, okay, per cycle. So the turn size increased by 76%. Because of these two factors, the productivity or efficiency of cable logging was actually doubled in machine cut area compared to hand cut area. So this is the difference in efficiency is reflected in treatment cost here. So hand cut area versus machine cut area. This bar, the entire full bar, indicates the cost of moving wood from stump to landing only. Okay. But if you look at here, machine cut versus hand cut, if you look at only felling component, which is light blue, the machine cut is a lot more expensive because we use a lot more expensive machines. I mean, very expensive machines. So if you look at only felling component, machine cut is a lot more expensive. But because of this efficiency gain in cable logging after timber falling, you can see here the dark blue is a lot smaller in machine cut area, even though we use the exactly same yarder and exactly same crew. Okay, so overall, the total cost from stump to landing, okay, machine cut area, we were able to reduce the cost by 30%. Okay. So anyway, so this gives an idea of what we can do through a paired study, and especially if you collect time study data, okay, in the type 3 treatment implementation. So again, hopefully that gives an idea what we can do. And this kind of I summarized what we can do, even though we don't really know what kind of equipment we're going to use and exactly where it's going to happen and so on. But if we want to compare this treatment, conventional treatment with variable density thinning operations, for example, then probably we can look at the size and density and pattern of skips and gaps. So how those skips and gaps in terms of size and location and pattern affect the productivity of individual machines or system, as well as the cost of timber production. Okay, and to do that, depending on the terrain, whether it's a cable ground or a tractor ground, okay, we can collect different the external variables here, and then our hypothesis is that unit treatment cost or production cost will go up as we have more, larger or frequent skips. Okay? So that's the kind of hypothesis that I came up with. And also we can compare conventional practice with complex or early cellular treatments. And in this case, probably we can look at the location and size of leaf tree clumps, okay, how they affect the cost and productivity of this treatment, and also amount of slash left behind harvest. And we can look at the trees per acre, each treatment, and also the system difference between cut to length system versus whole tree. Okay, so equipment is going to be completely different. You know, the way the operation is completely different. So we can compare those if we apply those different systems in a similar terrain and vegetation conditions. Okay. So and then riparian areas, I don't think we can really do paired studies, because paired study works when we can do a similar job but in different ways. But riparian, basically, it's like a absence and presence, whether we do it or not. So I don't think the the paired study works for riparian. But through time study, we can measure how long it takes to cut down trees and move trees into, or place trees into the stream. We can measure the time and then estimate costs of the treatment. Okay, through time study. And then for thinning operations, we can do time study to look at how the thinning density would affect the productivity of machine and overall cost as well. Okay. So with that, that was the end of my presentation.